Assalamu alaikum students. I'm back with the second video on connected particles. Okay, so I have been showing you this again and again that this is the book that we're using, the mechanics for A-level mathematics mechanics. Okay, so I'm on to page number 110 example. It is 5.1. I'm just going to read out the question. It says a car towing a trailer travels along horizontal straight road. The car has mass 1500 kg and the trailer has mass 500 kg. The resistance to motion is 80 newton on the car and 20 newton on the trailer. The driving force produced by the engine of the car is 360 newton. Find the tension in the tow bar. Okay. Now, so here is the car over here. Okay, so the mass of the car is let me write this MC. Mass of the car is 1500 kg, and the mass of the trailer, that is given as 500 kg. Okay, the resistance to motion is 80 newtons on the car. So I'm just going to write this F on like frictional force on car is 80 newtons, and the frictional force on trailer, that is equal to 20 newtons. Okay, and it says the driving force produced by the engine of the car is 360 newtons. So we have the driving force over here, that is 360 newtons. Okay, so we have to find the tension in the tow bar. So here is the tow bar. We have, like, this is the tow bar. So we have to find how much tension is over here. Okay, now let me show all these forces over here. The mass of the car is 1500. So though we don't need to show this weight right now because it is moving on a horizontal surface, I'm still showing this just for the sake of showing. Okay, this is R on the car, and here is the weight of the trailer, and that is going to be 5000 newtons, and here is the R on this trailer. Okay, we have a driving force which is 360 newtons over here. Okay, and the frictional force on this car is that is 80 newtons. Okay, and the frictional force on the trailer, that is 20 newtons. Okay, and here is the friction. Like I have to show, we have to find this tension in this this tow bar. Okay, so as I was telling you that we can consider this as one system, or we can look at them separately as well. So for example, we had to find the acceleration. Okay, this is just an example. So if you had to find the acceleration, so you could have taken this as one whole system as well. Like for example, if you take this as a system, so you have to see that what is the forward force on it. So that is 360 newtons. That is a forward. That is the driving force. And what is the backward force? So that would be 80 plus 20. Okay, I'm just going to do this over here. The forward force is 360, and the backward force is going to be 80 plus 20. That is 100. Okay, this is 100, and then the mass. Total mass would be 1500 plus this 500, that is 2000. Okay, so this is going to be 2000 times this A. Okay, so this is going to be 260 over 2000. That is the acceleration. Okay, this would be, I think that would be 0.13. Yeah, this is 0.13. Now this would be really interesting for you guys to know now that if we take them separately, you will see that we shall get the same acceleration. Okay, now look at this. Since we have to find this tension in this tow bar, so we should be considering them as separate particles. Okay, so now we shall take this car separately and take this trailer separately over here. Okay, so if you consider this car right now, so then you see that the forward force on the car is going to be 360. Okay, And what is the backward force? There are two backward forces. One is this frictional force, which is 80 Newton. The other is the tension in this tow bar. Now look at this. When you consider this car, so you will be taking this tension, like, because this trailer, obviously it has got some weight, there is a frictional force acting on it. So the motion of the car with the trailer and without the trailer is obviously going to be different. Okay, so this trailer is because of this trailer, there's a tension on this tow bar, and which is going to be T. Okay, so I shall be writing this as 360 minus T plus 80, and that is equal to MA. The mass of the car is 1500 A. Okay, so if I just simplify this, I think I should get 280 minus T, that is equal to 1500 A. Okay, that is what we get from the car. Now we look at the trailer. Okay, for the trailer, obviously there is no engine in the trailer, so there is this tow bar. So because of this tow bar, this is moving with the car. So we shall be taking this tension for the tow bar. So there is the tension T, which is forcing this to move, and there is this frictional force 20 newtons, which is going to be minus 20, and its mass is 500, and this is A. Now look at this. This is really interesting. If you just add these two equations, you will see that the T's getting cancelled. Okay, and you get 260 and equal to 2000 A, and this equation is the same as we got over here, that is 260, that is equal to 2000 A. So I was telling you that you can consider this as one object as well. Okay, but to determine this T, you had to take them separately. Okay, so now if you solve them simultaneously, first of all you will be able to get the acceleration by adding them together. You will get the acceleration definitely 0.13 meter per second square, and then you put this acceleration back into this equation, you will get the tension in the tow bar. Okay guys, I have a same kind of a question here from this exercise 5A. If you look at this exercise 5A's question number 1 is ditto the example that we have done. I'll be doing its question number 2. It's absolutely the same as that example, but just to reinforce your concept, I'll be doing this question. Okay, I'll be reading it out and I'll be drawing this as well. Okay, now it says a car of mass 1200 kg tows a trailer of mass 300 kg. The car and trailer travel along a straight horizontal section of the road. Okay, so here is that straight horizontal road. So here is the car with me, and this is the tow bar. Okay, and here is the trailer. Let me just draw this a bit smaller. Okay, now we're given that the mass of the car is 1200 kg. So mass of car, like a good student always write down the given information very clearly. Okay, and the mass of the trailer is going to be 300 kg. You should have this information in your solution, and if you have that fully labeled diagram, you will not have to look at your statement again and again. Okay, the car and the trailer traveling this, the engine of the car produces a driving force of 400 Newton. Okay, so that means we have a driving force, that is 400. I'll just be showing this in the diagram in a minute. Okay, the car experiences a resistance of 150 Newton. Okay, so the frictional force on the car, that is it is where am I? Yeah, 150 Newtons. Okay, and the force of friction on the trailer, that is 100 Newton. Okay, and he's saying that find the acceleration of the car and the trailer, and then he says find the tension in the tow bar. Okay guys, so I'll be again, since we're given these frictional forces over here, so I don't need to show the weight and then the normal contact force over here. Okay, so I'm not going to show that thing right now. I'll just be showing that there is the forward force, which is 400 newtons. okay, the backward force on this car is 150 newtons, and the backward force on this trailer, that is 100 newtons, okay. And obviously we shall show this T and this T over here. Okay, so you must be clear that this trailer is moving because of the motion of this car, okay. Now he says find the acceleration of the car in the trailer. So to find this acceleration, guys, I would suggest you take this as, like, you know, as one system over here, okay. Like on the whole there is a forward force of 400 acting over here on this system, okay, and there is a backward force of 250 newtons, like, you know, if you add these two forces together, and their collective mass is 1500, okay, and you get the acceleration through this. So I think this is going to be 150 over 1500, and that is going to be the acceleration, okay. So that is 0.1 meter per second square, okay. Now it says the second part, find the tension in the tow bar. Now when you find this tension over here, now you will have to consider these two car and trailers separately, okay. So if you look at the car's motion over here, so that will just look at this, because this car is moving horizontally, so there is a horizontal force of 400, that is a driving force, okay. And then there is the tension in the tow bar, and then there is a frictional force, and that is equal to MA, that is going to be 1200 A. So please be very clear, this is the forward force 400 newtons, okay, and the tension in the this is the tension acting on this car, okay, because of this trailer, and this is the frictional force over here. And if you look at this trailer, uncle trailer over here, so trailer is moving because of the tension in this tow bar, okay. So this is the tension that is making it move, okay. This is T, and then this is backward 100 newtons over here. This is T minus 100, that is equal to the mass of the trailer is 300 A, okay. So look at this, this is going to be 400 minus 150, that is 250 minus T, that is equal to 1200 A. And look at this, if you add these two equations, you will get this equation back, okay. So we have already got this acceleration, so you just put the acceleration in any of these two equations, you will get the tension in this tow bar, okay. So yeah, we didn't need to write these two equations, but just to show you guys that, like, you know, if you're taking them separately, you can always have two equations over here. And this is basically, this will be happening very typically in case of these connected particles. You will mostly be having two equations through that F equal to ma, and then you will be solving them simultaneously to find the tension and the acceleration, okay. Now from here on, I'll be moving towards the third video of this chapter. That would be, like, you know, from the next exercise, and, like, you know, the only difference would be now we shall have the things, the string going over a pulley, okay. So let's meet in the next video. Do not forget to share this video, to subscribe, okay. If you subscribe, you share, you like, I'll be encouraged, I'll be motivated, okay. Thank you.